So welcome back. In today's video, we are going to talk about software architecture. Now, this software architecture of a program or the computing system is actually a depiction of the system that aids in the understanding of how this system is going to behave. And this particular software architecture serves as the blueprint for both the system and the project developing it, defining the work assignments that must be carried out by design and your implementation teams as well. So, your architecture is the primary carrier of system qualities such as your performance, your modifiability, security, none of which can be achieved without a unifying architectural vision. So basically, your architecture is an artifact for early analysis to make sure that a design approach will yield an acceptable system or not. Right. So let's see another definition which is given by Bas, Clements and Kazman in your software architecture in practice, the second edition. It's a very popular book as far as your software architecture is concerned. So three people, Bas, Clements and Kazman. So software architecture of a program or a computing system is the structure or the structures of the system which comprises your software elements, externally visible properties of those elements, and the relationship among them. So what are the things we are going to have? Your software elements, externally visible properties of those elements, and the relationship among them. Now, so your architecture is about your visibly external, which is like what is visible externally and not about the internals. Right, I'm not going into details about the internals, that how my JDBC, ODBC bridge driver is going to work. These things will not be there in my software architecture. The implementation detail of a component are not architecture, right? How I'm going to implement it, this is not the part of the architecture. So basically, your software architecture of a particular system will be describing its major components and their relationship and how it is going to interact with each other. Your software architecture and then design includes several contributory factors such as my business strategy, the quality attributes, the human dynamics, the design, and your IT environment. And further, we can segregate your software architecture and your design. And this segregation can be into two parts. One is your software architecture and the other one is your software design. In your architecture, non-functional decisions are cast and separated by the functional requirements. So basically, your software architecture is nothing but a blueprint. This blueprint is of a system which provides you an abstraction in order to manage your system complexity and establish the communication and the coordination mechanism among various components. So now let's once again revisit that particular definition which was covered few minutes back from the second edition. Now this time let's cover it from the third definition. So just a minor change, the software architecture of a system is the set of structures needed to reason about the system structures needed to reason about the there is a repetition which comprises your software elements, relations among them and properties of both. Now let's see what ISO IEC 42010 says. Right now we are talking about this ISO standards, and this particular standard is derived from the systems and software engineering. Which basically talks about the architecture description. So this particular standard for systems and softwares. So it defines your requirements on the description of system, software and enterprise architecture. And basic aim is to standardize the practice of architecture description by defining standard terms, presenting a conceptual foundation for expressing, communicating and reviewing the architecture, along with specifying the requirements that apply to architecture descriptions and your architecture frameworks as well. So what we do is we define the things in terms of your architectural design, fundamental concepts, your abbreviations, description language, frameworks, viewpoints and whatnot. Right, so this particular standard says that software architecture is your fundamental concepts or the properties of a system in its environment embodied in its elements, relationships and the principles of its designing and evolution. So this was like this particular definition is from your ISO IEC 42010, and we have several goals as well. Now let's talk about your software architecture which has been defined by IBM. So what it says is, an architecture defines structure. It also defines behavior. An architecture focuses on significant elements. So we are not going into the technical details of the implementation part, but basically we are focusing on your structure, behavior, elements, and then your architecture balances the stakeholders' need. It embodies the decisions based on certain rationale as well. Everything has a reason, right? So it is based on certain rationales. An architecture may conform to an architectural style as well, right? Even in case of building architectures, we say that okay, this is based on Dutch style. A particular building is based on, let's say, American style. So in case of softwares also we have several architectural styles as well. An architecture is influenced by its environment. And it also influences your team structure as well. An architecture is present in every possible software system. System here means your software system. Because right now we are talking about software systems, because hence it is about software systems, but in actual it is present everywhere. And an architecture has a particular scope as well, and I can reuse my architecture as well, software architecture to be very specific. Reusability factor is there. Now let's see the role of the architect. So what architect gets is the requirements from the clients or the end users, and what architect creates is the architectural design. And on this side, your architect is in touch with developer in order to provide the solutions. So what architect has provided is the architectural design, which can visualize the appearance or the behavior, which can further be assessed by my client and the end users. So that means based on this set of requirements, the architect has created an architectural design which visualizes the appearance or the behavior, which can be further assessed by my clients on this side. So this is the left hand side of this diagram. Whereas on the right hand side, the same architecture prescribes the construction and the cooperation, right? Because I get a blueprint, right? As we previously discussed, just like the infrastructure, we get a blueprint with the help of our architecture. Here also, in case of software systems, I get a blueprint which can further be assessed by the developers as well, because developer will also give some input that okay, the architecture which you have provided has some implementation related issues, right? So here also you can see there is a two-way communication. So developer also communicates and provides some inputs which can further be accepted or maybe rejected, desk rejected, based on the kind of inputs provided by the developer and the kind of requirements we have. That means like some inputs can be desk rejected just because it is not matching with the actual requirement, right? So it's like, if you carefully see that all my stakeholders are involved in this, because on this side I have my clients and users, on this side I have my developer, and architecture is sitting here, and there is like communication going on, two-way communication going on at every end, and I get an image of how my system is going to look like, just because I have this architectural design which can visualize the appearance or the behavior of this particular software system. So from this particular diagram, you might have got some idea that okay, how handy it is to have a software architecture. Alright, so let's look into a time when the software architecture was not included in the software development lifecycle. That means we are now going to talk about the pre-architecture lifecycle. That means when the architecture was not included in the software development. So what we had was like, we had the stakeholders who provided us these requirements, and we have incorporated the quality, went for an agreement, went for development. and we are done. So this is happening in case of your pre-architecture life cycle, right? But whereas if you see this, now this particular section is missing, right? This particular section is missing. That means my client is not able to visualize, my client is not able to assess, and hence there are chances that when the product is ready, my customer might be, the end customer or the client might be unhappy with the product. So we came up with some alternatives that, okay, let's add the architecture in simplest possible way. So in this software development life cycle, what I have done is I have added the architecture in the simplest possible way. So what is happening here is we got the stakeholders view and we went for refining the requirements. We added the quality and got the agreement. And then we are going for a development where I have the architectural design, we have the detailed design, and then we are going for implementation. So this particular section is okay. But once again, the stakeholders are not able to get the view of this architecture, right? That means the stakeholders are once again not able to visualize that how my software is going to look like, how it is going to behave. So what we have done is we brought some improvement as compared to the pre-architectural life cycle, but yet I'm still not having the overall end user's involvement, where the end user is going to give me some inputs based on the architecture and the detailed design. That means based on these two phases. So what we can do is, let's bring in the architecture in the life cycle. So what we are going to do this time is we came up with the stakeholders. All the stakeholders are there. We have the requirements, we have the quality aspects, we came up with the architecture, and then we can refine it, right? We can keep on refining it till the time my stakeholder is not happy. Once the stakeholder is happy, let's go for the agreement and then go for the development. So all the changes are happening at this end. Now this is something which is very much convenient for everyone. That means if I am supposed to bring some changes, let me bring some changes at a very early stage of software development life cycle. Right, at a very early stage of software development life cycle. Instead of developing the product and then making my end user unhappy, it's better to make him realize that how my system is going to behave and how my system is going to look like. So this is the best possible way in order to incorporate the software architecture in my software development life cycle. Now let's see the various importance of software architecture. So it helps us in understanding the system, which ultimately leads to handling the complexity as well. And since I'm able to visualize it, I'll be able to organize the entire development process as well, and that too very much in a very efficient manner. I can take the early design decisions as well, right? At a very early stage, I can take a call on, what all changes I need to bring to the overall design. Here only I'll take a call based on the architecture. I'm going ahead with the agreement or not. Here only I'll take a call. So bring some changes, incorporate it. So since software architecture is transferable and reusable model, so it can be used for multiple applications. right? It can be used for multiple applications. Now let's look into the various goals of software architecture. So what all possible goals we have? One is expose the system that means how my system is going to look like and how it is going to behave, but hide the implementation details. Now how it is going to benefit me is, that means I may not reach to the agreement stage with my end client. In that case, what I have done is I have only exposed the system. I haven't exposed the internals of it. So I can use the same system in order to convince someone else as well. Now the software architecture realizes all the use case scenarios. It addresses the requirements of various stakeholders. It also handles the quality elements or your non-functional requirements. And since I'm getting feedback from the visualization part, that too from the end users, so I can improve the quality as well. And I can get the satisfied customers as well. That's my ultimate goal is. Since there was a continuous involvement and inputs received from the end users, so definitely I'm going to have the satisfied customers as well. Now, along with all these goals or the advantages, there are certain limitations as well. Right, there are certain limitations of these software architectures. The limitations are like there are still lack of tools and standard ways. Although lot amount of standardization took place, but still there are some issues. Now there is still a lack of analysis method to predict whether the software architecture will result in an implementation that meets the requirements. That means I may get a false impression that the architecture might be giving me the actual desired results, but in actual it is not. So that we still lack those methods in order to do some analysis. Then we may come across a situation when we identify that there is a lack of understanding as far as your software architecture is concerned. So these are the limitations of software architecture. And now let's look into the qualities of a software architect. Qualities of a software architect. So the first thing is that a software architect should be a design expert. That means he or she should be expert in software design, including the diverse methods and approaches such as your object-oriented design or your event-driven designs, and can lead the development team and coordinate the development efforts for the integrity of the design. The architect should be able to review the design proposals and the trade-off among themselves. So apart from being a design expert, the architect should be a domain expert. The architect should be the expert on the system being developed and plan for the software evaluation. The architect can assist in the requirement investigation process and assuring the completeness and the consistency as well. He or she should coordinate the definition of domain model for the system being developed. See, domain expert should have the idea about all the business logics and all the domain related points which can be incorporated in order to come up with a software solution. And then the software architect should be methodological. Reason being, the architect should use the appropriate approaches for the development which can help the entire team as well. Then there are certain hidden roles of a software architect, where it is expected that the architect can facilitate the technical work among the team members and can be an information specialist who can share the knowledge and should have a vast experience. The architect should protect the team members from external forces that would distract them and bring less value to the projects. Then we expect certain deliverables which are like your clear and complete functional goals. It can deliver the concept for the system, a document or a process which can ensure your functional decomposition which is allowed or not, and can form the interfaces whenever controlled. Now there are like several varieties of architectures. We have like software architecture, we have like solution architecture, we have logical architecture, we have technology architecture, we have information architecture, then platform architecture, and then technical architecture. And your list is not limited to these. We have your system architecture, and then we have the code architecture, we have the deployment architecture, we have enterprise architecture, we have the application architecture, we have the conceptual architecture. Now let's talk about enterprise level softwares, right? So that means we are talking about enterprise architecture right now. We cannot cover all those things, but we'll talk about enterprise architecture and the solution architecture. So while application architecture concentrates on the architecture within some form of notional application boundary, your enterprise architecture looks architecture along or across a large enterprise. And such an organization is usually too large to group all its software in any kind of cohesive grouping, thus requiring coordination across teams with many code bases. And these code bases are actually developed in isolation from each other. So there needs to be a coordination. Much of enterprise architecture is about understanding what is worth the cost of central coordination and what form that coordination should take. Now let's look into your solution architecture. So what we have is this is a very simple possible architecture. So we have the requirements from which I am getting this solution architecture, which can further be managed or engineered. And the solution architecture can be of varied form, which can further be managed and engineered. So one of the simplest possible solution architecture. Now let's look into the evolution of enterprise architecture. So from 1960s to 70s, we had in around 60s, we had monolithic applications where we had non-shareable data files, which has resulted into your modularized applications. Now these applications are in the form of various modules interacting and communicating among themselves. And then instead of having the non-shareable data files, I have the shared database right now with me. Right, so that kind of changes we have observed in the recent past. And then from 1990s to 2000s, what changes we have? Like we have the presentation layer, your topmost layer. We have modularized applications and shared database. And from there, what we have got is your process and workflow is on the top. Then we have the presentation layer. Then we have like shared business components. We have shared databases. And we have the rule engines which is interacting with this presentation layer and your shared business service components. So in the enterprise architecture, now what we have is like all these things are connected, and with the help of these process and workflows and the rule engines, I have the presentation layer. The database is shared here, and to all sections of an enterprise, I will be serving with the help of integrating all these applications and coming up with this architecture. Now this is all about enterprise architecture, where we said that okay, I have many code bases I have incorporated, and these code bases were working in an isolation, and now all these components are coordinating among themselves. Many times this enterprise architecture faces issues just because all those code bases which are running in isolation are the outcomes of poor decision makings and poor designs. So it becomes tough to initiate the coordination among these modules. And it becomes tough to come up with a central architecture which is communicating with all these small applications which are running in various ends. So it's like, let's say in our university system, I can have an inventory management system, I can have one attendance management system, I can have one course management system, I can have one library management system, I can have a payroll management system, I can have an admission system. Now these, let's say 6-7 systems are running in isolation. So I need to come up with an enterprise level architecture which can integrate all these components, and the communication starts between these software components. So what will happen is, like, all these components will start sharing data among themselves, and there will be a presentation layer which will be presenting the data after fetching from any possible shared databases, after fetching data from any possible shared databases. And if we, let's take the previous scenarios, right, in case of early 1990s, or maybe if we go back further, right, when we had the monolithic applications and the non-shareable data files, in that case, if the data files I cannot share, I cannot afford to integrate these modules and come up with a single application, right? So it will become tough to have like all those small applications which are running, and then I'm integrating all these things and coming up with this, and these modules are initiating interaction among themselves, because already I have like non-shared data files. In case of shared database, up to some extent it is possible, because now I have like the application which is already in modules. So up to some extent it is possible, but not fully, right? Not fully. In 1960s, I cannot even imagine. In 1970s, up to some extent it is possible, but no. In 1990s, yes, some amount of ease is there, but still I lack the rule engine. I lack the rule engine, and hence the efficiency will not be there. Right. So the full business automation is not possible. The full business automation is not possible in that case, but yes, in the current one, with the help of rule engines, I can easily go ahead with integration part as well. So this was all about software architecture. So from this list, we talked about software architectures. We talked about solution architecture as well. And we talked about enterprise architecture as well. So these three, because the list is huge, we cannot cover all those things, but for this discussion, I guess this much is sufficient. So this was all about today's video, and in the next video, we are going to talk about software requirements engineering, and there we'll look into various functional requirements and your non-functional requirements. We have already talked about these functional and non-functional requirements, and now we are going to formally cover these requirements and the various categories and what it means, and then further sub classification and so on and so forth. So let's meet in the next video.